Hello everyone and welcome to Mathematics. So for this video, we'll focus on chapter 5, progressions, and let's aim ourselves to learn two things from this video. Alright, so I'll let you have a few seconds to go through the question first. Alright, so for part A, we have Ryan uses these colored triangular cards of different sizes. So if you look at diagram 8, these black triangle cards are actually the colored triangle cards. And you can see that here there is this white color inverted triangle. This is actually not one of the cards that Ryan has. This is actually a blank space. It's actually surrounded by these three triangle cards. Okay? So why is he doing this? Because he wants to investigate the pattern of this Spienski's triangle. Right, so let's look at this diagram 8 to see what is this about. So for the first stage, we have this one triangle which has a height of 40 cm. Okay? And going to the second stage, we still need to form this 40 cm triangle, but we only can use triangles which has half of the height of the triangle in the first stage. So means the triangle here will have a height of 20 cm. Okay, and to form this triangle, we need to have 3 of them. So going to the third stage will be the same thing as well. We need to cut the height by half. So in the third stage, the triangles will have a height of 10 cm. And to form this triangle, we need to have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 triangles. Okay, so for the blue numbers, this is actually the pattern of the number of triangles. And for the red ones would be the height of the triangle. Okay, so going to part A, we need to find the height of the triangle which is used in the 7th stage. So we need to find the 7th stage triangle's height. Okay, so if you look at the pattern of height of triangle, you can see that it goes from one value to the next. We need to divide by 2, or we need to multiply 1 over 2. Correct? So for those sequences which needs to multiply or divide a number to get the next number, it's actually a geometric progression, or GP. So since going back to the question, the 7th stage triangle is actually the 7th triangle, which is T7. So to find this height, we can use this formula. And we need to find out the value of A and R. Okay, so value of A is the first term, which is the height of the triangle in the first stage, which is 40. And for the R is actually the common ratio, which is the number required to multiply to get the next number, which is 1 over 2. Okay, so we can set these values inside to find the height of the triangle. Okay, so our A is 40, our R is 1 over 2, and our N is 7. So you'll get 0.625 cm. And for the second part, we need to find the number of triangle used at the last stage if the height of the triangle for that stage is 5 over 64. Okay, so here there's a few things we need to know first. So the first thing is, which stage is the last stage? Like which stage has this height of 5 over 64? This we don't know. So we need to find the value of n first. Okay? And the second thing we need to know is we need to understand the pattern of used triangles. So this one we actually have it already. It's just we need to find the value of A and R of this pattern. Okay, which is here. And once we have these two things, we can find the number of used triangles. Okay, so let's go back to the first part. We need to find the value of n. So we can use back the same formula we have just now, but here the different thing is we don't substitute the value of n because we don't know. Okay, so here Tn, and we equal to the height of the triangle, which is 5 over 64, and we sub the formula of Tn here. So our A is 40, our R is 1 over 2, and here we remain n minus 1. And now we simplify this. So for this 512, I can change it to a number whereby it is 2 to the power of something. So here we need to take a guess, okay? Or we can substitute the values one by one. You can try 4, 5, 6. So here the answer will be 2 to the power of 9. Okay, and for the left side, this power I will apply to numerator and denominator. Okay, so it will look something like this. Okay, so for here, for the value of the power, no matter what it is, like for let's say 1 to the power of 100, it will still be 1. If it's 50, it will still be 1. So no matter what value is in, no matter the value of power, it will always be the value of 1. Okay? And here we don't change anything because we cannot simplify. So why are we doing these things? Because we can compare the value of the power for both sides. And I can write it to an equation. N minus 1 equals 9. So here will be n equals 10. So this means the 10th triangle has this height 5 over 64. Okay, now we need to find the pattern of used triangles. So here our A will be 1. Okay, because the first stage has this only one triangle, and the R, which means from one number to go to the next, this is to multiply 3. Okay, so R would be 3 in this case. So now we can find the number of used triangles. Okay, so let's look and see for the 10th stage how many triangles we need to use. Okay, so for this T10 we can still use back the same formula. So our A would be 1, and our R would be 3, and the N would be 10. So here the answer would be 1, 9, 6, 8, 3 triangles. So for part B, it is given A is the first term and R is the common ratio of this geometric progression. And if modulus R is more than 1, we need to show that the sum of first n terms formula is this, which is what we learned. So this is actually a new thing in the SPM syllabus. We need to prove the formulas that we have learned before. Okay, so let's list out all the formulas we have in geometric progression. Okay, so there are only two, Tn and Sn. Okay, so obviously to prove this we cannot use these two. So the only thing we can use is this, Tn. So we need to find the relationship between Sn and Tn. So since Sn is the sum of the first n terms, we can list out all the things inside. For example, like this. Here we list out from the first term to the last term, which is the nth term. Okay, and for all the terms, I will need to transform them to become this expression, ARn minus 1. Okay, so if you look at the second line, you can see that T1 it becomes A, because if I substitute n as 1, it will become AR power of 0. So R power of 0 is actually 1, so we will only have A. Okay, and it applies to all the terms. So this Tn minus 1, if I substitute n with n minus 1, you will get AR n minus 2. Right? So this is our first equation. So if you look back the equation that we need to prove, there is this minus, but our equation here does not have minus. So we need to subtract something with the first equation. And you can see that in front of this, there is this R. So we need to minus something which has an R and minus with this first equation. So one of the ways is we can multiply the whole equation with R, which is something like this. Okay, so here we have Sn to become Rsn, and here A will become AR. Same goes to all of the terms. Alright, so here will be our second equation. Right, so now we can subtract the second equation with the first equation. So from the left side, it will be Rsn minus Sn. And for the right side, there is a lot of repetitive stuff. Okay, for example, here AR, we need to minus the equation above, so here AR we need to cross it off. AR squared as well, AR3 as well, it will be in the middle, so it will be crossed off until there's only two values left, which is ARN and A. Okay, so here we just need to write ARN and minus A. So now we can factorize out the things which are similar. So let's say for the left side is Sn, and for the right side is A. Okay, and then we can move the r minus 1 to the right side. And you can see this is actually the equation that we need to prove. Okay, so we have completed the question. But you may be wondering that, okay, so if I want to prove this equation would be something like this, but what if the question asks to prove this equation? Alright, so it is actually the same thing. The only thing which is different is here we minus the first equation and with the second equation. So it will be the opposite way. So here, if I do this, left side of the equation will be Sn minus Rsn. And for the right side, it will be the opposite as well. It will be A minus ARN. And the remaining steps is the same. So we factorize Sn, and here we factorize A. And we move 1 minus r to the right side. So here we will get this equation. Alright, and with that, we have completed today's question. Alright, so here's the take-home points for this video. So the first thing is, for these kind of application questions, we need to understand it is a AP or a GP question. So if you see when I discuss the video, you can see that I will list out all the values above the triangle to see what is the pattern. Okay, so if we need to multiply or divide a value to get to the next number, it will be a GP. If it's need to plus or minus a value to get the next number, it will be AP. So keywords you can see maybe longer or shorter for AP, and GP you can see keywords like double or half. Right, and for the second take-home point would be steps to prove Sn. So first thing, list out the things inside the Sn. And for the second step is to multiply r to the first equation we got. And then the third step is either we minus 1 minus 2 or we 2 minus 1. Okay, depending on which formula you are trying to prove. Alright, so here's the answer scheme for this video, and hopefully you have learned something new from this video. So if you feel this video is beneficial to you, please give a like, subscribe, and share. So I will see you all in the next video. Thank you.